Okay, good morning. Welcome to
Math problem number 37.
Math Problems number 37. So today we're going to learn about the divisibility rule for 6. And up to now we have been studying divisibility rules. Like we learned the divisibility rule for 2 is the number has to be even.
Yeah.
For 3, the sum of the digits is a multiple of 3. Right? For 4, we found you only have to check the last 2 digits. So what does that mean?
So like...
It means like the number 912. We know that's divisible by 4 because 12 is divisible by 4.
Yeah.
And what's the reason that this rule is true, by the way?
Because 4 goes into 100.
4 goes into 100, so that we know goes into 900. Okay, and on 3, sum of the digits, that means we can know that 63 is a multiple of 3 because 6 plus 3 is 9.
Yeah.
Okay? Alright. 5, if a number is a multiple of 5 if it ends in 5 or 0. Multiple of 10 if it ends in 0. But now we're going to look at multiples of 6. So here's a few just to start. 6, 12, 18, 24, 36, 30, 36, 42, 48, 54, 60. Okay, so let's see if we can figure out, is there a rule for multiples of 6?
Well, something I noticed is I think you skip every first and second even number to get to these.
Ah, okay. So we're only catching some even numbers, but what do you notice about these numbers? Are they all even or are they all odd?
They're all even.
Okay, so these numbers are all even. Okay. So that kind of sounds like a lot like this rule.
Yeah.
Except not all even numbers are divisible by 6. So tell me a number that's divisible, tell me a number that's even, but not divisible by 6.
Well, 16 isn't.
16, yeah. Or 2, or maybe 34.
Yeah.
Okay. So one thing these numbers all have in common are that they're even.
Yeah.
Okay, but it turns out that's not a good enough rule for divisibility by 6 because there are even numbers that are not divisible by 6.
Yeah.
Alright? So we've got to find something else that's the same about these numbers.
Well, 3, the sum of the digits is a multiple of 3. Well, some of these numbers add up to 6.
Oh, the sum. Okay, so let's look at the sum of the digits. Here it's 6,
6,
3, 9,
6,
3, 9, 6,
3,
12. 4 plus 8.
12.
5 plus 4 is 9, and then 6. Okay. So, the sum of the digits, is the sum of the digits always a multiple of 6?
Well, no, there is 3 and 9, but it just keeps going.
Well, it looks like
6, 3, 9, 6, 3, 9.
Yeah, it looks like there's a pattern. I'm not sure if that pattern is going to continue for forever because it might change. But there is something interesting in these numbers: 6, 3, 9, 6, 3, 9, 6, 12, 9, 6. What's interesting about those numbers?
I think they're all multiples of 3.
Ah, interesting. They're all multiples of 3. So it looks like the sum of the digits is a multiple of 3. Huh. So if we have an even number where the sum of the digits is a multiple of 3, maybe we get a multiple of 6. Which rule was this, the even one? This was a rule for the multiples of
2.
This is a rule for multiples of
3.
What is 6?
6
Is
is a multiple.
how does 6 relate to 2 and 3?
Well, 6 is even, and 6 is also a multiple of 3.
6 is 2 times 3. So if a number is divisible by 6, it's divisible by 2 and 3, right? So we have to use both rules. Even and the sum of the digits is a multiple of 3. That's pretty cool, right?
Yeah.
So we can quickly check that 63 is not a multiple of 6, even though the sum of the digits is a multiple of 3 because it's not even.
Yeah.
But we can also check that 120... 120. Sorry, I had to think for a second. 120 is a multiple of 6. The sum of the digits is
3.
3.
And it's
even.
even.
Alright, there we go. Good job, sweet pie. There's your multiple of 6 rule. Maybe tomorrow we'll talk about 9. Ooh.